Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at angle pairs. So today's learning target is I will apply my understanding of angle relationships to calculate the missing angle measure. So these are a lot of vocabulary that we're going to be looking at today. And the first term we're going to be looking at is adjacent angles. You might have heard of the word adjacent before. Adjacent angles are simply angles that share a common side and a common vertex, and they don't overlap. Together, they form a single larger angle. So what I'm going to do is I'm going to zoom in and we're going to label our adjacent angles. So in this visual, I can say that angle AOB and angle BOC are adjacent. So angle AOB and angle BOC. If I wanted to, I can also just simply put numbers next to them. If I wanted to, I can say angle 1 and angle 2 are adjacent. If you want to, you can typically just number them. That's what I would prefer that you do because it just makes it easier for everyone else. Now we're going to look at the angle addition postulate. The angle addition postulate is going to be the one that we most commonly use because it's just one of the go-to postulates. The angle addition postulate simply states that the sum of two adjacent angles equal the whole angle formed by the two angles. So simply, if I look here, 26 degrees, 33 degrees, 26 plus 33 is equal to 59 degrees, which means that my whole angle right here has to be 59 degrees. So if I want to, I can basically say part plus part is equal to my whole, or angle ABC plus angle CBD equals my whole angle, angle ABD. Now we're going to look at the angle bisector. The angle bisector is very important as well. An angle bisector is simply a ray that splits an angle into two equal adjacent angles. So if I look at this visual right here, I have angle Q and angle P. They both have a semicircle and a tick mark on the semicircle, so I can say angle Q is congruent to angle P. I can also say that 2 times the measure of angle Q, or 2 times the measure of angle P, is equal to the measure of my whole angle, in this case, angle HGI. That's just another way we can look at this. Now we're going to be looking at perpendicular lines. Perpendicular lines are also very special in this course, and whenever you see this symbol, we're dealing with them. It's basically an upside down T. Perpendicular lines are lines that intersect to form right angles, so they are going to basically be creating 90-degree angles every single time. Complementary angles are two angles whose sum is 90 degrees. They are not necessarily adjacent. Here's a trick you can use to remember it. So if I have the word complementary, I can simply just draw a 9 down it, and boom, I have a 90-degree angle. That's how I can remember complementary. So right here, I have 25 and 65. 25 plus 65 is 90. And that would be your final answer. That's basically just showing you that you have a complementary pair of angles. Now let's look at supplementary angles. They are two angles whose sum is 180 degrees and they're not necessarily adjacent. So basically whenever you see a straight line, you have supplementary angles. To figure out your trick, I can just do supplementary, and I can make an 8 out of my S. So I know supplementary angles have to add up to 180 degrees. So in this case, I would say A and B are supplementary to each other. Let's go on to some problems where we actually use the algebra behind what we did today. For our first example, we have the measure of angle YWZ is 67 degrees and the measure of angle XWY is 54 degrees. What is the measure of angle XWC? The diagram is not drawn to scale. So the first thing we do is we label our image based off what they have provided to us. I know that the measure of angle YWZ is 67 degrees. So I go to my image, start at Y, go to W, and end at Z. That means this angle right here is 67 degrees. I now know that the measure of angle XWY is 54 degrees. So I start at X, go to W, end at Y. So I have two parts, and I want to find the value of angle XWZ. So I start at X, go to W, and end at Z. So I want to know my whole angle. My whole angle. So I know that part plus part is equal to my whole. So I can just do 67 plus 54. And what's 67 plus 54? Yep, that's right, 121 degrees. So I can say angle XWZ is 121 degrees. And that's your final answer. Let's go on to the next example. In this example, the measure of angle JKL is 169 degrees. The measure of angle JKN is 13x plus 2. And the measure of angle NKL is 28x plus 3. Find the value of angle JKN. So the first thing we do is we label our image. So I know JKL is 169, so I start at J, go to K, and then end at L. So I know that my whole angle is 169 degrees. And that's a whole. Now, JKN is 13x plus 2, so I start at J, go to K, end at N, 13x plus 2, and then NKL is 28x plus 3. So I start at N, go to K, end at L. These are both two separate parts, so I have part plus part is equal to my whole. Whenever you have x's, you need to find x. So I know that I can do my equation as 13x plus 2 plus 28x plus 3 is equal to 169. What I want to do now is I want to combine my like terms. So 13x plus 28x is 41x. 2 plus 3 is 5, and that's equal to 169. I want to get x by itself, so how do I get rid of a plus 5? I subtract 5. So I'm going to subtract by 5 on both sides. So 169 minus 5 is 164. And then to get x by itself, I divide by 41 on both sides. My 41s cancel, and I get x is equal to 4. But here's the issue. Was the question asking you to find x or to find an angle? Yep, it was asking me to find an angle. So I simply want to find angle JKN. So I know JKN is 13x plus 2. And everywhere I see an x, I'm going to plug in 4. So I get 13 times 4 plus 2. 13 times 4 plus 2 is just going to be 54 degrees. And that's your final answer. Number 4. Well, actually, should be number 3. I made a typo. We all know I don't know how to count. Given the diagram below, what is the measure of angle GEF? Well, if I look at my visual, I want to find out what this angle is right here. So GEF, I know it's A, and I know my other angle is 2A minus 9. I know that this whole angle, though, is equal to 90 degrees. So part plus part is equal to my whole. So I just do 2A minus 9 plus A equals 90. The first thing I do is I combine my like terms. 2A plus A is 3A. So I get 3A minus 9 equals 90. I have to ask myself, how do I get rid of a minus 9? Well, I add 9, so I get 3A equals 99. And now to get rid of my 3 that's being multiplied, I divide by 3 on both sides. So A is equal to 33. But here's the issue. The question wasn't asking me to find A. It was asking me to find the measure of angle GEF. So I go to my visual, start at G, go to E, end at F. So I just want to plug in A into this expression, which is just A. So I can say that the measure of angle GEF is just 33 degrees. And that's your final answer. Let's go on to the next question. This works for both of these examples, so EF goes to number 5 and number 6. So occasionally you're not going to be given a visual. It says EF bisects angle DEG. So the first thing I'm going to do is draw angle DEG. So start at D, go to E, and at G. And I know EF is my bisector, so I'm going to draw in EF. And now we're going to label our image. I know that the measure of angle DEF is 5x minus 3. So I start at D, go to E, and then end at F. I know that the measure of angle FEG is 2x plus 15, so I'm going to put a 2x plus 15 in here. And I want to find the value of x. Well, I know that EF is an angle bisector, so I know that these two angles have to be congruent to each other. So I'm going to put a tick mark on both of them. So if I want to find x, I just set them equal to each other. So I do 5x minus 3 equals 2x plus 15. Try to solve this equation by yourself. If you solve that equation correctly, you should have subtracted 2x from both sides, leading you to get 3x minus 3 equals 15. Then I add 3 to both sides, and I get 3x equals 18. And then I divide both sides by a 3 to get x equals 6. That is your final answer. Now we're doing the exact same visual down below. I'm going to draw it in. So in this question, I know that the measure of angle DEF is 3x plus 1. So I'm going to put that in my image. DEF is 3x plus 1. DEF is 3x plus 1. And the measure of angle DEG is 5x plus 19. Well, if I look, DEG is my whole. So I have a part and a whole. So I know that my whole angle has to be 5x plus 19. Here's the issue. I know that I have an angle bisector, so I know that this angle is congruent to this angle, 1 and 2. So if angle 1 is 3x plus 1, angle 2 also has to be 3x plus 1. So what I can do is I can do 3x plus 1 plus 3x plus 1 equals 5x plus 19. I combine my like terms. 3x plus 3x is 6x. 1 plus 1 is 2, so I have 6x plus 2 equals 5x plus 19. I subtract 5x from both sides. 6x minus 5x is x plus 2 equals 19. And then I get rid of my plus 2, I subtract 2. Subtract 2, subtract 2, x equals 17. And that's your final answer. And that's it for today on angle rules. If you have any questions, please don't hesitate to email myself, Miss Daniel, or attend Extra Help. Again, have a great day, ladies. Please message me on Remind if you have any questions.